Hello students, week 16 physics for grade 11, chapter 34, lesson 11 electric power, textbook page 693 to 694. At the end of the lesson you will be able to relate the electric power used by a device to current and voltage. Unless it is in a superconductor, a charge moving in a circuit expends energy. So a charge moving in a circuit expends energy. This may result in heating the circuit or in turning a motor. So electric power is the rate at which electrical energy is converted into another form such as mechanical energy, heat or light. You learned mechanical power, that was actually work done over time, and you know that work done means conversion of energy from one form to another. So generally power means energy converted in a particular time. So you can say rate at which electrical energy is converted into another form is called electric power. Electric power is equal to the product of current and voltage. Electric power equal current times voltage. So this is another formula for electric power. If the voltage is expressed in volts and the current in amperes, then the power is expressed in watts. So for the unit for power is watt or watts. The power and voltage on the light bulb read 60 watts and 120 volts. So you have seen when you buy electric bulbs or any other electrical appliances, written the input voltage required and the power of the particular device. So the current that would flow through the bulb is I equal to P over V, because you learned the formula for power as I times V. So here I equal to P over V, 60 watts divided by 120 volt equal to 0.5 ampere. So you can find the current from the given power and voltage. A lamp rated at 120 watts operated on a 120 volt line will draw a current of 1 ampere. 120 watts equal to 1 times 120. So you are getting 120 watts. So it means the current will be 1 ampere. A 60 watt lamp draws 0.5 ampere on a 120 volt line. So you can get all these things if you apply these given values in the formula. A kilowatt is 1000 watts. You know, kilo means 1000. So kilowatt hour represents the amount of energy consumed in 1 hour at the rate of 1 kilowatt. Where electrical energy costs 10 cents per kilowatt hour, a 100 watt light bulb burns for 10 hours for 10 cents. Cent is actually for United States. In our case, the electrical company have a particular amount of money or cost, you can say, for a 1 kilowatt hour. A toaster or iron, which draws more current and therefore more power, costs several times as much to operate for the same time. Toaster, iron or electric heater, such devices, air condition, they actually draws more current, so definitely cost more to operate such devices. Can you find the answer here? How much power is used by a calculator that operates on 8 volts and 0.1 ampere? If it is used for 1 hour, how much energy does it use? Okay, look at the answer. Power equals current times voltage. So 0.1 ampere is given and 8 volt, these are given actually in the question, so you can simply multiply, you get 0.8 watts. Energy equal power times time. So 0.8 watt times 1 hour, because it is mentioned in the question as 1 hour. 0.8 watt hour, convert this into kilowatt hour, so it will be 0.0008 kilowatt hour. Now another question, will a 1200 watt hair dryer operate on a 120 volt line if the current is limited to 15 amperes by a safety fuse? Can two hair dryers operate on this line? So it's better to know these kind of things, because you are going to handle many electrical, or you are handling many electrical appliances, and of course you are handling many types of electric circuits. So can you find the answer? Okay, look at the answer. One 1200 watt hair dryer can be operated because the circuit can provide 15 times 120, so that will be 1800 watts. But there is inadequate power to operate two hair dryers of combined power 2400 watts. In terms of current, 1200 watts divided by 120 volt equal to 10 ampere. So the hair dryer will operate when connected to the circuit, but two hair dryers will require 20 ampere and will blow the 15 ampere fuse. So this is the calculation. Now concept check question. How can you express electric power in terms of current and voltage? Try to find the answer. Thank you and see you.